Hello, good afternoon. I am Madhura Prakash Sawan from ADCI. I am studying in 11th batch 6. Today we are today we are going to learn little bit about gravitation. So let's start. First of all, we see the contents of presentation. First, what is gravitation? Second, Kepler's law. Third, universal law of gravitation. Then come to the point of what is gravitation. First, all materials objects have a natural tendency to get attracted toward the earth. In many natural phenomena like coconut falling from trees, raindrops falling from the clouds, etc., the same tendency observed. All bodies are attracted towards the earth with constant acceleration. This fact was recognized by Italian physician Galileo. Every mass of object in the universe experiences gravitational force. It is a force of mutual attraction between any two objects by virtue of their masses. It is always an attractive force within infinite range. It does not depend upon intervening medium. It is much weaker than other fundamental forces. Then we then we see Kepler's law. Law of planetary motion describes the orbits of the planets around the sun. Kepler's published the first two laws in 1609 and the third law in 1619. These laws are the result of the analysis of the data collected by Tycho Brahe through year of observations of the planetary motion. First law of Kepler, law of orbit. The law of orbit states that all planets move in elliptical orbits around the sun with the sun at the one of the foci at the ellipse. In this figure, S and S dash are the foci of the ellipse. The sun being at S, P is the closest point along the orbit from sun and is called a perihelion. A is the farthest point from the S and is called the aphelion. In this figure, PA is the major axis, which is 2A. PO and AO are the semi-major axis, which is A. MN is the minor axis, which is 2B. MO and ON are the semi-minor axis, which is B. Kepler's second law, law of areas. This law states that the lines that joins a planet and the sun sweeps equal areas in equal interval of times. Kepler observed that planets do not move around the sun with uniform speed. They move faster when they are near to the sun, while they move slower when they are farther from the sun. This is explained by this law. And third law was law of periods. Law of periods state that the square of the time period of revolution of a planet around a sun is proportional to the cube of the semi-major axis of the ellipse traced by the planet. In this figure, if r is the length of semi-major axis, then this law states that t square by r cube equal to k, where k is constant. Kepler's laws were based on regular observations of the motion of planets. Kepler did not know why the planets obey this law. That's why he not derives this law. Then we solve a question on this. The question is, what would be the average duration of year if the distance between the sun and the earth becomes thrice present the distance? Solution. If R1 is equal to present distance between the earth and sun, the time taking earth revolves around the sun is 365 days. If R2 is equal to thrice of R1, then according to the Kepler's law of period, T1 square is equal to R1 cube and T2 square is equal to R2 cube by R2 cube. T2 square by T1 square is equal to R2 cube by R1 cube. Therefore, T2 by T1, which is equal to R2 by R1, 3 by 2, is equal to 3R1 by R1 raised to 3 by 2. T2 by T1 is equal to root 27. T2 is equal to T1 into root 27. T2 is equal to 365 into root 27. T2 is equal to 1897 days. Therefore, 1897 days average duration of year if the distance between the sun and the earth becomes thrice of the present time. Then our last point, universal law of gravitation. Newton's law of universal gravitation states that Every practical in the universe attracts every other practical with a force directly proportional to the product of their masses and inversely proportional to the square of their distance. Universal gravitation Universal gravitation equation can be written as F is equal to G m1 m2 by r square. Here, F is the gravitational force between the bodies, and m1 and m2 are their masses. R is the distance between the centers of the two bodies, and the universal gravitational constant denoted by universal gravitational constant is G is equal to 6.673 into 10 raised to minus 11 Newton meter square per kg square. Thank you.